So the first STSE for the course in Unit 1 is called the Search for Other Solar Systems. And personally, I find this STSE to be very, very interesting. First things that you need to know about this STSE is that we're talking about the universe versus a solar system. So you have to remember that a universe is very big and it incorporates several different solar systems. You also need to know how to define a solar system. So a solar system is simply a star that has planets orbiting around that star. So in the case of our solar system, we have our central star, which we call the Sun, and we have various planets like Earth and Venus and Jupiter that actually orbit that Sun. So that is the definition of a solar system. When you consider which planets in a solar system are actually suitable for life, you have to consider which planet is located in the habitable zone. So the habitable zone is that sweet spot or perfect location away from the Sun where water can actually exist as a liquid on the surface. So Earth, for example, is in the sweet spot or the habitable zone or the Goldilocks zone, whereby it's not too warm and it's not too cold because it's the perfect distance from the star, so that water can actually exist as a liquid on the surface. Not a lot of people realizes this, but we have found about 1,500 different solar systems out there at this point in time. So that's 1,500 solar systems besides the one that we currently live within. There are 5 different ways that you can go about finding a solar system, and I'm actually going to do a different video on how you actually, how each one of those methods actually work. So there's the radial velocity method, there's the transit photometry method, there's the astrometry method, the microlensing method, and the direct imaging method. And so within the STSE, there's a really good description in terms of how each of these methods are used. So out of the 1,500 solar systems that are found, to date, it's safe to say that one of these 5 methods was the method used to find those. A few terms and important, I guess, things that you need to know about from the STSE is the definition of the word transit. So a transit is any time that a planet passes between a star and the Earth. So if you were on Earth and you were looking out at a star, maybe belonging to another solar system altogether, and that star appears to be bright in the sky, and all of a sudden the brightness of that star disappears, and then give it some time and the brightness of the star comes back. What may have happened is a transit. So there could have been a planet that you couldn't see because planets don't give off light that passed between you on Earth and that star in the other solar system, which thereby blocked the light from that star. So that's what we call a transit. And that totally relates to one of the methods called the transit photometry method. The definition of an extrasolar planet, that would be a planet that is found outside extra of our solar system. There are 2 missions that we have in the world that are of major significance, and one is Gemini North. The Gemini Observatory Program has been in an operation by Canada, and its purpose is to actually find planets that are outside of our solar system. And the powerful telescopes remove the effect of twinkling stars, thereby allowing for clearer views out into space. They also minimize star light, thereby allowing for more focus on light being given off by the extrasolar planets. So that's one cool thing that's actually going on. Then there's the Kepler mission, is designed to survey a portion of our region of the Milky Way galaxy to discover planets that are about the same size of Earth that are in or near the habitable zone. And determine how many of the billions of stars that are in our galaxy that actually have such planets. So to date, we've actually found 1,500 that are possibilities. The theory for solar nebula formation is the solar nebula hypothesis, which we already talked about in a previous video. It infers that a solar system should have a rocky inner planets towards the inside, and the larger gaseous planets should be much further out. So if you can visualize what stage 4 of the solar nebula hypothesis looked like, you'll remember that all the rocky planets like Earth and Venus and Mercury were closer to the star, and the larger planets like Jupiter and Saturn were further out. We have found that the solar systems found do not fit the pattern described above for some of the 1,500 that we have found. They've actually found some large gaseous planets that are actually really close to the parent stars. Maybe gravity and friction has caused the larger planets to move. We don't really know, but we're now thinking that the solar nebula hypothesis could be a little bit too simplistic. Now, that's not something that you would have to know or consider for the public exam, just simply stating that maybe the solar nebula hypothesis is still a little bit too simple, and it's probably a little bit more difficult than we realize. When a planet outside of our solar system is found, the light they emit is very significant. This is because the atmosphere surrounding each planet influences the light that gets emitted. So right now what we're trying to do is, out of the planets that we have found, especially that are in habitable zones, we're trying to work with the light that we're actually receiving from those planets to see if they actually do have an atmosphere, and is it of the composition similar to Earth's, so that it could possibly support life. Again, something more complex that you would not get on a public exam. Just wanted to. This SDSE proves the importance of advancements in scientific methods and technology. So, like I said, we thought solar nebula hypothesis was the be-all, end-all, and we still think it to be true from an hypothesis type of definition. But at the end of the day, we're also thinking that it could probably be a little bit too simple. Yeah, we found 1,500 other solar systems. Yeah, we're looking at good technology in terms of identifying those and things like that, but we still have a way to go. There's no doubt about it. And so in my next video, I will take the 5 methods for finding a solar system, and we will break them down into how each actually works.